Hello, welcome to Math 1324. This is Chapter 5, Section 2, and this is going to be the first example. In this example, we want to find a formula for the future value of an annuity. Now, there's a key word here, well, a couple of them. Annuity. All an annuity is it's multiple payments over time. For instance, if you put money into a bank, let's say every month, and you did that for 10 years, how much will you have in the bank at the end of the 10 years with a certain amount of interest that is earned, let's say monthly? And so notice that we're going to have to take into account each individual payment because we're going to basically use compound interest a lot here. And so we need to find some formula to represent that future value. And so let's go ahead and look at that. So let's say we have this as a timeline. So I'm going to label these. So this capital N that I'm using is going to represent the total number of payments. And for us, capital N really does represent little n times t, where little n is the number of compounding events per year, and t is the time in years. And also for us, I'm going to let I represent r over n. Now, if you remember, the formula for the future value using compound interest is this. So if I replace r over n and n times t, that means that the formula that I'm going to be using is p times 1 plus I to the capital N power. Now, I'll put a kind of a, I don't want to use n here then. Let's use k. There we go. Now what this says is that these are each of the payments. So the first payment, second payment, third payment, and then this little symbol just means that this pattern continues forever until we reach the k minus 1 to the kth payment. In other words, there's a finite number of payments. And I do include 0 on here because there are such things as annuities due, which is what happens when you start making a payment at the beginning of a period instead of at the end of a period. So for us, we're going to work with ordinary annuities, which means that you're going to wait to make your first payment. Now you're used to this because most of your annuities that you've ever seen are all ordinary annuities. For instance, if you're making payments on a car, if you buy a car, you don't have to make payments until 45 days, right? Generally speaking, unless you make it a little bit sooner. So that's generally what's happening. You don't make the payments at the beginning, you make the payments at the end of the period. And by the way, this is the reason why the end in the calculator on the TVM solver is always what we're using. Okay, so let's look at this. For the first payment, you're going to make a payment at the end of the first year. So it's actually going to be right here. So if you make a payment there, and I want to know how much is that payment going to be worth at the end of the number at the end of the number of payments. Well, let's think about it. You start here and you go all the way this way, right? Well, if you make the payment at the end of the period, you don't get any interest from this period. But then you do make a payment here, or you've made the payment here, so this is going to be compounded here, here, and so on and so forth. So if it goes 1, 2, notice it's always 1 less than this, so whenever I get over here, the future value of this is going to be whatever that payment is, P. Well, let's not use P, let's use R. R for revenue stream. So I'll go and change that up here. Oh, that is a capital R. There we go. R times 1 plus I to the, now there aren't K of these, there are K minus 1. Now for the second payment, you'll make a payment starting here at the second here. So from here, going all the way to this payment right here, well, what would the future value be? It's that payment R, and I'm just going to put an R here for each one of these, times 1 plus the interest rate to the, but notice that this time it's not going to be K minus 1, it's going to be K minus 2, because we actually are having one less of a period to earn interest. So we have K minus 2. And then we do the same thing for the third period. For the third period, there's a revenue going all the way over here. So the future value is going to be R times 1 plus I to the K minus 3. Now notice that the K minuses for all of these are always going to be right here. Okay, so it's whatever, this first one, K minus 1. Second one is K minus 2. Third one is K minus 3. And so on and so forth. So if we continue this pattern, let's look at the K minus 1th payment. At the K minus 1, well, the future value is going to be R times 1 plus I to the K minus 1. No, just sorry, to the first power. It's the, yeah, it's to the first power because we have one payment here, or one period here to earn interest. Then for the Kth, here's the reason that it works. It's the K minus the K minus 1 here. If you distribute the K, or distribute the negative value, that's going to give you the 1 plus I to the K minus K plus 1. And then K minus K, of course, cancels. And so we're left with R times 1 plus I to the first power, or just 1 plus I. Now, as for the Kth payment, that Kth payment is just made at the very end. There is no interest there, so the future value is just that payment itself. Okay, so let's look at this. We want to add all of these up if we're going to find the future value. So add this up, add this up, add this up, add this up, that one, all the way to this. And so I'm actually going to go from the bottom to the top. And what this is going to look like is let's say the future value, or the accumulated value, will be the last payment plus the previous payment, which was R times 1 plus I, plus, and then of course the one before that would be R times 1 plus I squared, and then plus a whole lot of those, and then we reach these up here. We have R times 1 plus I to the K minus 3, plus R times 1 plus I to the K minus 2, plus R times 1 plus I. Oops. Let's make that a little bit smaller. Good. Okay, now I'm going to do something crazy here, and I'm going to multiply both the left-hand side and the right-hand side by 1 plus I. And the reason that I'm going to do this is because, well, frankly, it'll make it easier. So if we have 1 plus I times A is equal to R times 1 plus I, and then R times 1 plus I squared, because all I'm doing is I'm distributing this to each one of these terms. So R times 1 plus I, then this R times 1 plus I times the 1 plus I becomes R times 1 plus I squared, and then the next one is plus R times 1 plus I cubed, plus all the way down, and then R times 1 plus I to the, now K minus 3 plus 1 for the exponent, because notice that all I'm doing is I'm adding 1 to these exponents. So k minus 3 plus 1 would be k minus 2. And then plus r times 1 plus I to the k minus 2 plus 1 will be k minus 1. And then plus r times 1 plus I to the k minus 1 plus 1 would be k. Good. Now, why did I do that? Well, frankly, it's because these two are just true. These are the future values. This blue is equal to the blue, and this green is equal to this green. And notice what happens if I subtract these two. So let me subtract this from this. So that's going to give me, use pink here. I'll show it in blue here. So if I have the A minus the 1 plus I times A, so that's simply going to be the R plus the R times 1 plus I plus the R times 1 plus I squared plus the dot 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 plus the R times the 1 plus I to the k minus 3 plus the R times the 1 plus I to the k minus 2 plus the R times the 1 plus I to the k minus 1. Now, let's look at the green portion. We're going to subtract off the entire green portion. And notice that we have R times 1 plus I. I'm going to put that underneath the R times 1 plus I here. So we have R times 1 plus I, and then, first of all, it's a big parentheses, plus the R times 1 plus I squared, plus the R times 1 plus I cubed, plus the R times 1 plus I, well, sorry, there's the dot 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 at this point, the ellipse, and then the R times the 1 plus I to the k minus 2, plus the R times the 1 plus I to the k minus 1, and then plus the R times the 1 plus I to the kth power. Good. Awesome. Now, here's why I'm doing this. Notice that this term, subtracting off this term, they cancel. This term and this term cancel. And then there is a third term in here right here, so that'll cancel with this one that's not shown. And then the R times 1 plus I to the k minus 3 has one in here that's not shown, so that'll cancel. Then R times 1 plus I to the k minus 2 cancels. So all of these cancel, and that's important to see. So that and that, that and that, that and one in here, and then that and one in here, and all that, those ellipses, they'll all cancel. And then that and that, that and that. And notice that what we're left with is just R times, or R, and then minus the R times 1 plus I to the kth power. So what we really have is A minus the 1 plus I to the 8th power, sorry, not to the 8th power, A minus 1 plus I times A is equal to R and then minus R times 1 plus I to the kth power. Now for us, this capital K is actually our capital N, which is little n times t, just a reminder of that. Okay, so notice that there are, in these two terms, there's a common factor of a. So if I factor the a out, I'm left with 1 minus 1 plus I in parentheses. Then over here, I have an r in common, so I'm going to factor out an r, so that's going to be r times 1 minus 1 plus I to the kth power. Good. Now, over here, if I distribute the negative, the 1's cancel and I'm left with a negative I. So what I have is just negative I times A is equal to the R times the the 1 minus, then 1 plus I to the kth power. Awesome. Now, here's the thing. I need to divide by this negative I, so that means that A is simply going to be R times 1, excuse me, 1 minus the 1 plus I to the kth power, all over the negative I. So the future value is this, but that's not actually the formula we want to use because there's a negative down here. So what I'm going to do is I'm going to multiply both top and bottom by -1, but I'm going to distribute that into here. I'm not going to make it times the negative, or I'm not going to multiply it by the R there. So we have R and then times -1 plus the 1 plus I to the capital K, all over just I at that point. But we don't like having that negative go first, so for our formula, what we really like to do is make this to be 1 plus I to the kth power, and then -1 all over I. Awesome. And if we replace the i's and k's with everything that they are, the formula that we're going to want to have is this one. And a lot of people don't like putting the R here. They like to put it out front, which is perfectly fine because it's one big factor of the numerator. So the final formula that I'm going to give you here is this one. Okay, good deal. This is the future value for an annuity. Okay, so this R here is what I'm going to call the revenue stream. Just so that it begins with an R. And the reason that I'm calling it that is, that looks like a B, doesn't it? The reason that I'm calling it that is because you're making payments over time. So someone is receiving that money over time, and it's multiple payments over time, right? So it's a stream of money that you're giving someone. Or you can be receiving that as well. But this little r and little n and t are all the same as normal. So little r is the interest rate per year. Little n is the number of compounding events per year. And little t, of course, is the time in years. And a is still just the future value. Or if you will, the accumulated value. Good. And what's very interesting about this formula, here, we'll leave that on there. What's very interesting about this formula is that this R is just right here. So the revenue stream is just here, right? And then all of this is just some multiplicative number. That's all it is. And so the higher the interest rate, or the more times you compound in a year, the higher this number is going to be. And of course, the longer you leave it, the longer that this happens, the higher this is going to be. So there you go. In order to figure out the future value, you really just need to figure out this and then multiply by how much ever payments you make a month. Now, this is assuming, of course, that these are what we call level payments. So this is just an ordinary annuity where it's a flat payment over time. Good deal. Now, you may be wondering, can we use the calculator for this, for the TVM solver? And the answer is yes. In fact, the TVM solver is probably the main way that you're going to want to solve these, but for those of you that just want to use the formula, here it is. Alrighty. Well, there you go. This entire thing was just to arrive at that formula. And I can't even fit it on my screen. Awesome. Anyway, there you go. I will see you in the next video. Have fun.